met one another again here in Cyprus. All your space.
But I can manage. Hello, it's good to see you, Dr. Aya. Welcome to Cyprus. And hello everyone, good afternoon. I am Bertuğ Özarısoy. I graduated from the University of East London last March, so I am a newly graduated. I am an early career researcher, and this afternoon I will give you a presentation about my PhD research, which I was completed at the University of East London. So, the title of my presentation: Developing a Novel Methodology to Calibrate Building Energies in the Southeastern Mediterranean Climate. So, I will prove my claim at the end of my speech today. Here we go. I just want to acknowledge my supervisors. First, Professor Bertuğ Brown, and second, Associate Professor Anka Sikrala from the University of East London. So I won't be able to achieve my PhD without their support, particularly during the peak period of the pandemic. So I'm so thankful to them. Here we go. This is the table of contents of my presentation, but I will give you a brief information about the novelty of my methodological framework, which I developed particularly for the Southeastern Mediterranean climate. We are in Cyprus. My project primarily considers the island of Cyprus. For this study, we selected pilot study location and the pilot housing stock, which is located in Famagusta. So our international students may not be familiar with the location of Famagusta. Famagusta is located in far eastern part of the island, and it is the coastal city. And the housing stock, which is selected as a representative typology, housing typology for this study, is located in the density part of this city. And according to the Copenhagen climate classification, Cyprus has shown hot and dry climatic conditions. Bear in mind, the climate is the most important aspect of the PhD research, and I will demonstrate the outcomes later on during my speech. As you can see, the humidity reached up to 90%, almost 100% during the summer. And as you can experience from today, Cyprus has hot and humid conditions. And as a part of the Mediterranean islands, we enjoy the most of the sunshine. So the southern radiation factor is the most important part of this research. This brings us to identify the nationally representative housing stock, and this is the most important aspect of this PhD research. We look at the Eurostat data, and then we identify that the 27% of households live in apartments in Cyprus. We also look at the census data, which is gathered from the State Planning Organization of Northern Cyprus, and as you can see from this graph, the younger generations are on the rise. So we have a young generation at the moment in northern part of Cyprus. So this brings us to identify the archetype housing stock. We spent a gargantuan amount of time to identify what type of housing is appropriate for the generalization of the finding. And then according to the data, we found that the medium-rise apartment blocks, which was built between 1985 and 1995, are the most representative. So as you can see, this type of housing stock it was built across the island without considering any environmental design factors. And then we particularly focus on this housing typology. We also look at the integrated GIS data to aggregate the housing stock accurately for the foundation of this doctoral thesis. And then we found that the 38% of the built stock represents the residential building typology. And these graphs on the left-hand side demonstrates the residential stock, which was built between 2015 and 2019 in 5 major cities in northern part of Cyprus. We also look at the energy consumption, and as you can see, the housing sector accounted for the 48% of the energy use in northern Cyprus. So this brings us to identify the focus of this study. And the aim of this study is to develop an evidence-based energy policy framework for energy integration and implementation of the energy performance of buildings directives. As you can see that the Republic of Cyprus has been enforced to implement the energy performance certificates, but in northern part of Cyprus we have no such this kind of regulation, and this research is primarily sits on this ground, but it was developed step by step throughout my PhD process. And the first contribution of the knowledge is to develop energy policy design by implementing energy performance certificates of the buildings. Second, develop the thermal comfort by integrating the household's actual data into the simulation model. And then the fourth one, to develop a building regulation and assessing energy use and develop a particular method of design for the complex building energy simulation parameters. And this brings us to identify the novelty of the study. And the novelty of the study is, of course, developing an evidence-based energy policy framework. First, we integrated the GIS data to aggregate the housing stock, and then we identify the representative housing typology. As you can see from this flow diagram, we identify the medium-rise residential housing stock with such a poor condition. And then we integrated the households' actual energy use data to identify their thermal comfort and assessing energy use. And this brings us to question about the thermal comfort. So what is the purpose of looking at thermal comfort in this particular Mediterranean climate? We'll look at the ASHRAE Global Thermal Comfort Database 2, and we identified that there is only one study considers the occupant's thermal comfort, which was conducted by the researchers from Tunisia. And there is no any other data available for this particular Mediterranean climate. So this brings us to work closely with the researchers from the University of California, Berkeley, to develop our model to identify the thermal comfort thresholds. And then we developed this interface in collaboration with the researchers. And then we integrated our field survey data to provide the most accurate, almost most accurate data for the identification of the thermal comfort. So this brings us to develop a novel. Novelty is based on the comprehensive methodology which were applied in certain amount of time throughout the PhD process. First, survey. Second, environmental monitoring. Third, building performance evaluation. Fourth, multi-objective optimization, which brings us to develop energy evidence-based retrofit policy design for this particular climate. So, as you can see, the human data sits on the top of this flow diagram. So we gather the data from the survey, we identify the nationally representative housing stock, and then we calibrate the simulation method in several times. First, including the building performance evaluation, and second, optimization. So this brings us to identify the questionnaire survey based on in 3 different parameters. First, household socio-demographic characteristics. Second, thermal properties of the buildings. As you are an engineer, this means that the we look at the U values of building parameters and we integrate them into our simulation model. And thirdly, we look at the energy efficiency systems. And as you can see, we install the weather station on site to monitor actual environmental condition parameters while I was distributing survey to the households. Second, I conducted in-situ measurements. I also used thermal imaging camera to understand the thermal performance of the building envelope itself. As you can see on the left-hand side, I gathered them into highly efficient chips developed particularly for my PhD research.
If you start to...
Okay, just give me a second. Sorry, apologies, wait. And then we assess the building, we assess the building topic, building thermal performance by using the thermal imaging camera in several times, and then we integrate data into the simulation model. And then we develop, this is the summary of the Python script, R script, which I developed particularly for this study, and then we developed a black box energy model to include all this data into the simulation model. And we integrated the several data sets into the model, and then we calibrate the building energy performance and occupant thermal comfort. We also use heavily across all my PhD research the statistical methods. I applied certain of statistical methods to provide absolute accurate information at the end of my PhD research. We integrated the household social-demographic characteristics. We also look at the household's occupants' behavior on their domestic appliances at home. And then we also gather the field survey data, and then we integrate them into the simulation model. I just want to share one important information. These are the results of the environmental monitoring findings. As you can see that the humidity in this particular location during my field survey, the humidity reached up to 90%. And as you can see that our climate is humid, but according to the Copenhagen climate classification, it indicates that Cyprus climate is hot and dry. So it demonstrates a contradiction within the Copenhagen climate classification. And at the end of this data, I found that in Cyprus, in naturally ventilated buildings, households feel thermally comfortable between 28.5 and 31.5 Celsius in this particular housing typology, which was selected for the study. And then we apply and we make a generalization of this thermal comfort threshold across the islands. And then we included the household's metabolic rate, activity, and protein insulation into our simulation model to make our model absolutely accurate. And then we also look at the thermal building topic thermal performance data into the simulation model, and then we also integrate the household's energy bills to validate the survey findings and simulation findings. And then I develop passive cooling design strategies by integrating 6 different design alternatives. And then at the end of this building simulation, I found that after the implementation of all these 6 strategies, we managed to reduce our 81% of energy consumption reduction is possible. And this is
Dr. Bertuğ, I appreciate it.
And this is I'm just nearing the closure of this part. And as you can see, this is the passive cooling design strategies which was applied onto this building envelope. And these are the outcomes which contribute to the energy policy framework and occupancy thermal comfort. And now today, because this is a comprehensive PhD research, I managed to publish over 30 articles and conference papers, which I managed to publish last 8 Q1 publications in a year time. And one important contribution to knowledge is the threshold, which I found as an output of my PhD research has been accredited by the Aşağı Global Thermal Comfort Society. And now Cyprus is located on this map as part of my PhD research output has been entailed to this global thermal comfort database too. And I just want to share the final outputs of my PhD research, because my PhD thesis is only a tiny bit of my work. And then we decided to develop the handbook, and the handbook of retrofitting high-density residential buildings, which will be published by Springer next month. So I'm in a stage of sending the proofs, and this is one of the major important outputs. As an early career researcher, and I'm in my home country, I have a glimpse of hope to create at least awakening call to tackle the energy crisis in our islands and beyond the southeastern countries. And thank you very much for listening to me, and this is the end of my speech. Thank you very much for everything. Thank you.
Thank you very much, Dr. Bertuğ, for presenting your works on energy efficiency of buildings in the Mediterranean climate, which was quite fascinating, and it ties in with the next book, which is online, and I would like my colleagues to bring up the